Hello there. Today I'm going to walk you through how to build a recurrent neural network for general purposes, and then I'm going to show you how to modify that to make it CUDA compatible. So first thing, let's just get right into our imports here. TensorFlow is TF. Okay. Import Keras. From Keras import optimizers, yep. And then from keras.models, we'll need to import sequential. And then from keras.layers, we can import several things here. We'll need to import dense, dropout, LSTM, and then CUDA LSTM, and I think activation. And then from keras.optimizers, import atom. So we'll be using the MNIST dataset. So just an easy dataset to use because it's widely available. You can just grab it from Keras like so. Keras.datasets.mnist. Okay. And then we can set up our X train and our Y train here, as well as our X test and our Y test. So the X train is the dataset that we're going to be using to train. And the Y train here is the labels for those. And then our X test is the data that we're going to be using to test. And as you might imagine, our Y test is just simply the labels for those. And then we're just going to say dataset.load data. So this just loads all of the data from Keras into here, into these different variables. So the first thing we want to do, the MNIST dataset is images. So you're going to want to normalize it. So simple way to normalize it is noting that images are colors usually from 0 to 255. We'll just normalize it by dividing it by 255. Same thing with X test. It's equal to X test divided by 255. Okay. So now we can just load our model here. So we'll say model is equal to sequential. And we'll say model.add. This is our first layer here, 128 nodes. And then for our input shape, what we'll be setting this to is our X train. Okay. And then for activation, we'll use ReLU, however you want to pronounce it. And then we're going to want to have return sequences to true in this case. And then we'll be adding a dropout layer. This just helps normalization. Dropout 0.2. You don't want to make it too high. There's some scenarios where we want to do like maybe 0.6, things like that. But in this situation, we won't be doing that. So then we'll do model.add LSTM. We'll do 128 again, sure. And we'll say activation again is ReLU. And then we'll do another dropout. Dropout 0.2. Cool. And then finally, that should be quite enough for the recurrent neural network layers. So now we'll actually drop down to dense layers here. So we'll do model.add dense. And we'll say 32 nodes here. If you have too many nodes, perhaps if you're inexperienced, you might think, oh, well, let me just add a bunch of nodes, because if you add more nodes, maybe we'll get better data, right? Better results. Well, actually, that will lead to something called overtraining, and it can actually just destroy your model completely, and you won't really be able to identify anything. So that's not what you want to do. And for your last layer here, we just added another dropout, and for our last layer, we always want to do softmax on dense layers for the last layer. Okay, so now we're going to set up our optimizer. So we'll just call it, let's call it opt. Is equal to, again, atom, which is a type of optimizer. And we'll set our learning rate to something small, but not too small. We'll do 1e -3. And then for our decay, we'll set that to 1e -5. Okay. And now we'll compile the model. So it's this model.compile. And we'll say loss is equal to, we'll do sparse categorical cross entropy. And then set up the optimizer there, again for that optimizer that we just built. And then the metric we will monitor is accuracy. Yeah, we'll do accuracy. Sometimes you might want to do dial accuracy, or sometimes you'll want to monitor several. Sometimes you want to monitor loss. It varies. Model.fit. So in this, we want to fit to our training set here. And then for epochs, we'll do 2. Validation data. We want to validate again on that X test and our Y test. Okay, so this should be good. Again, this is not running CUDA here. The first time we're building through this is not CUDA. So let's go ahead and run this. Error converting. Oh, oops, shape. I wonder how many of you all saw that. Okay. Yeah, I just didn't define the shape here. So it's loading now. This is just loading all the different CUDA libraries because I'm in a GPU environment, but that's not necessary for this go. So as you can see, really slow here. Training on 60,000, validating on 10,000, so it's going to train here on 60,000 samples. ETA about 1 minute 30 seconds, and then it's going to have to go through again and validate on 10,000 samples. All right, so you can already see the speed of this. It's pretty slow. So for speed's sake, I'm not going to make you sit through that. But what I'm going to show you to do now is how to change these to CUDA. So first of all, you need to change LSTM to CUDA STM, as we showed up here what we imported. And then you want to remove the activation layers on your CUDA LSTM layers now. Okay, that's it. That's all you have to do. It's pretty crazy. But now if we go ahead and run this again, I have a 1080, a GTX 1080. So it's going to go ahead and do this now. Flying through there. Look at that. Oof. It's at about 15 seconds. And if you're training on actually a really complex data set, it took 11 seconds. If you're training on a really big complex data set, GPU acceleration is just a must. I mean, look at that. We're already done. That's it. And we ended up with an accuracy of 96.75%, loss of 0.12, 10 seconds only on that last one. And it's 165 microseconds a step there. So GPU acceleration is just amazing. If you have any questions, let me know in the comments, but pretty short, simple video on how to do recurrent neural networks and then accelerating them with CUDA. Thank you.